Today we're going to look at the Xcentz xDynamo 5, which is a 5-port wall charger with Quick Charge 3.0. Model number is an AT25011. This charger has a total of 5 ports, 3 USB, 1 Quick Charge, and a USB-C. Each one has a 3 amp charge rating on it. Let's check it out. I haven't even cracked the seal on this one yet. We're going to open it together. And see what comes in the box. So here's the charger. Let's take a close look at this unit. You notice that it has 5 ports. It has 3 ports that are 2.4 amps. It has a Quick Charge 5 or Quick Charge 3.0, and it has a 3 amp Type C. So total of 5 ports. Remove the charger itself, and this charger you plug directly into mains. You don't need a separate adapter. Comes with a power cord. Let's take a look at the specifications on this thing, and then we're going to plug it in and put it through some of its paces, see what it can do. So it comes with a standard AC power cord and the charger itself and a set of instructions. So let's go over what the unit will do. So this one here has got 5 ports. Pretty simple. It operates from 100 to 240 volts at 50 to 60 hertz. Draws 1.5 amps. I guess that's when it's fully loaded. And here's the specifications. So the QC3 output, which is Quick Charge Spec 3, will support 3.6 to 6.5 volts at 3 amps. 6.5 to 9 volts at 2 amps, and 9 to 12 volts at 1.5 amps. And then the USB Type A outputs is 5 volts at 3 amps at maximum 2.4 per port. And the Type C output is 5 volts at 3 amps. Consumption's 48 watts when it's loaded down. It's got 5 ports. We're going to actually load this thing down. And this is do not use the charger in excess of its output rating. Do not put your fingers or hands into the charger. No kidding. Do not open or crush or bend and puncture the charger. Common sense stuff, right? Don't disassemble it. Take it to a qualified service person. Guess what we're going to do with this thing? We're going to take it apart. We're going to test it, and we're going to take it apart. So here's my test jig. I've got my resistor array, which will load down a 5 volt supply and draw about 2.4 amps approximately. We'll monitor the current when I plug this in. We'll monitor, I shouldn't say monitor the current, we'll monitor the voltage, and we'll see that at loaded down at 2.4 amps or 2.5 amps, because this is quite a big load, we're down at 4.19 volts. As you can see, it's 5.2 volts now, and we're going to drop it down a little bit because I am exceeding the maximum current for this particular charger. If we go over to the 3 amp capacity, you can see that now the voltage is still about 4.8 volts. So we're getting close to that, and these are going to get very hot very quick to the point where it's actually going to melt the solder on the resistors here that holds them together. Yeah, it's getting pretty warm. So that's a good load. If I want to see how much current I'm drawing, I can certainly grab my other meter. As you can see, something's wrong here. I'm only able to draw 1.7 amps. Well, it's not the charger that's at fault. It's actually my cheap jumpers that I've got here. If I remove these jumpers and hook my meter directly across without these jumpers, you'll find that the current actually does go up to what it's supposed to. So if I just wrap the wire coming from my USB lead around and touch my other jumper directly to it, you can see them actually drawing 2.3 amps now. Okay, so we've got a 50 watt light plugged into the 3 amp output. Will it run on there? It is running on the other outputs as well. What I'm curious is this a shared load, or is it a independent load? So I'll plug my load into a second port, and when I connect it here, will it shut down? Will this light go out? And indeed it does, because I've now exceeded the maximum current capability for these ports, which tells me that these are shared. At least those two are shared. Make sure, well, we don't need the meter on now. We know what it draws. Let's just see whether when I hook this back up, whether it will shut the light down. Because that will certainly tell me whether these outputs are shared. So when I plug this in, the light goes out because I'm exceeding the current capability of the output, which is limited to 2.4 amps. If I go over to this one here as well, again, it didn't shut down. Oh yeah, it did. My wires weren't tightly connected here. So it is, these three ports are shared. It's 3 amps maximum, 2.4 amps per port, but a total of 3 amps maximum. What about this other one over here? Is this one separate, or is this one also shared? And we'll find that this one here is a separate output. The USB Quick Charge 3 is a separate output, because when I plug in my resistor network is getting hot. I can't hang on to it. It's getting hot very quickly, and my light bulb is still working. So this one here is a separate output from the shared 2.4 amp max. So that's that, and it's getting this warm too. If I plug into the 3 amp one, it actually gets a little bit brighter, the light, because it's more current capable. And if I plug into these, as you can see, it's not going to affect the light. I forgot all about my little meter that I've got. Why mess around with digital meters and measuring current? I can just measure everything with this thing. So here we can play around with this 2 amp service, 2.5 amp meter, or 2.5 amp port. And if I plug my resistor network in here we go. Okay, now that's a little better. So 2.4 amps, my voltage just dropped to 4.79. This is eliminating the leads and everything else, which I was getting up against the resistance of my test leads. So here we go, 2.45 or 2.4 amps. Voltage drops to 4.78, which is totally acceptable. Same for all the ports here. All the ports are going to work the same. 2.4 amps, right? If I try to put that light bulb on here at the same time on one of these shared ports, we'll notice that it's going to shut off because it's going into protection. And if I plug it into the USB Quick Charge 3.0, of course it's still only going to go into 5 volts, but here's our current now. See, we're drawing 2.69 amps. So my resistor array actually is drawing more power. So it's limited to 2.4. So there we have our full output. If I want to test the other USB-C, I can plug in this adapter, and we can plug it into the USB-C port here, and we'll see that the USB-C port is delivering 2.43 amps as well. And I can plug my light bulb in to one of the other ports, and it will not cause the port to drop. Even on, and that's interesting. My light bulb is plugged in, as you can see. It's plugged into the USB Quick Charge 3, and my resistor that are getting hot now are plugged into the USB Type-C. We're drawing 2.4 amps still on here. So this one's obviously, these two are completely independent from each other. So this actually has 3 chargers in it. As you can see, the light is working. I'm drawing 2.4 amps through the Type-C connector, and I'm drawing full power through one of the 2.4 amp, and if I move it over here to the Type 3, as you can see, it still works. So this has actually got 3 independent chargers in it. 3 amps for the Type C, 3 amps for the QC3, and 3 amps that's shared between the 2.4 output maximum. So you can charge 3 devices, but they can't exceed 3 amps for all 3 of them. And you've got 3 amps for this one and 3 amps for that one. Let's plug it into my phone and see how my phone responds. And we'll do it both through this, measuring with this, through both the Type C port and the QC 3.0. So first I'll grab my adapter cable here, plug it in, get that light bulb out of the way for now. I'm going to grab my Samsung S9 phone and we'll plug in the USB Type C adapter so that we can see what the current draw for the phone is when I plug the phone in. If I can get this thing to sit here so you guys can see it without it falling down. Okay, plug in the phone and my phone says 1 hour to charge, and it's only charging at 1.4 amps at 4.95 volts. Let's just try plugging it into the QC 3.0 port. It's still only charging at 5.2, so it's not detecting that my phone is QC3 compatible. It might just be this cord that I'm using, and that might be the reason why it's not going into the higher voltage mode. But now it's gone to 1.7 amps, but it's still only charging at 5.2 volts. I'm going to go grab a fast charger that I know does charge at 9 volts, and we'll try that and see whether this will switch up, because I know that this does measure on my other charger. It measures 9 volts using a wireless charge pad. So I'm just going to go grab that wireless charge pad and see if the voltage will kick up. I've got my Blitzwolf charger. This is a QC3 device. As you can see, this has gone up to 12 volts. So when I drop my phone on here, it will kick into charge, and it's gone into fast charge now, and it's telling me that my charging will be still 1 hour and 3 minutes. But now it's charging at 11.9 volts, but only at 0.7 amps, because of course the current is lower when the voltage is higher. So the phone was charging at 4 volts or 4.8 volts before at over an amp. Now the amperage is starting to come up a bit, and that's how QC3 operates. It communicates with the phone and determines what charge rate it should use and automatically adjusts. So that's using the QC 3.0 output. If I go back in and plug it into this plug, the adapter, and plug that into the 3.0, it should also detect and switch up to, I think it's going to go to 12 volts. Maybe it doesn't over Type C. I'm not sure. I've never tried this before. It's 5 volts is what it's charging at. Drop my phone in, and interesting. So maybe this adapter here is only passing the standard USB-C. It's not passing the quick charge. But 1.4 amps, 4.91 volts through the Type C socket. And if I go back to that one, it's going to go up to 12 volts. and that's using the wireless charger. So it must be just my cord is only compatible with the lower voltage charging, which is interesting. You would think that it would also support the higher voltage. But apparently not, because over the USB-C to USB cable, it's only charging at 5 volts. But when I put it onto the wireless charge pad, it's kicking up to 12. So that's a real fast charge. I'm going to be probably using this in the house to charge devices now, because this looks like it could be, you know, the answer. I mean, I've got another one that I'm using that's a 4-port, and it does give me full current on each channel, whereas this one here is shared. So my other little charger that I received last year that was a prototype has 4 independent ports, and they do, each one's independent. This one's got 3 charge channels, 1 charge channel here, 1 for the USB-C, and the 3 regular ones are shared. 3 amps total. But as you can see, through my cable, it's only charging at 5 volts. And if I go through the wireless charger, it's going to kick up. And that's just because this charger, this Blitzwolf, is communicating with this charger and telling it it can do QC3. Well, I give up. I know I promised that I was going to show you guys what the inside of this thing looks like, and I probably just annoyed everybody by telling you I'm not going to be able to do it. But this thing appears to be glued together, completely glued together, which doesn't surprise me because it is an AC operated device running from mains voltage. So in order to get their certification, they're going to have the unit, you know, protected to the point where someone's not going to be able to get their fingers in where there could be high voltages, because this is a universal voltage. It'll operate from 100 to 240 volts, which means that on the capacitor is going to charge up. If you're powering this on 240 volts, that capacitor is probably going to be floating around 350 on the main input. So they want you to keep your fingers out of it. It looks like it's glued together pretty solid. And I thought maybe I could pop the top off, and this might be like a sticker or something on the top, and there'd be screws under here that I could open up and open the unit up. But it appears to be that it's completely glued shut. As I say, I want to use this unit myself. I'm going to be giving this thing a long-term test, because I have 3 relatively small loads that I can plug into here that I'll be using as a power supply, and those are clocks that I have built. So I'm going to be powering up a couple of clocks from the 2.4 amp maximum, and I can use the QC 3.0 to power up my wireless charger that you just saw, the Blitzwolf. I'm going to be using that port to power that up because it's a 12 volt, and I've still got the USB Type C, which I can use that adapter and get another USB output on that. So anyway, I'm going to end this now. Link to this little power supply is in the description, and yeah, it looks to be pretty solidly built. I say I couldn't get into it to see how the circuitry is, but looking at it from the outside here, this thing seems to be built like a brick. You know what? I mean, it's not coming apart easy, that's for sure, and it is putting out the rated power that it claims. So I'd have to give this one a thumbs up based on everything I've seen. Thanks for watching, and we'll catch you in the next one real soon.